Howdy ho, everyone. Welcome back to another API review. It is Tuesday, so we have 4 items. I think I promised them in the order in which they appear here, but I do not have preferences. Like if there's a different order proposal, we can shuffle things around.
So would it be possible to replace that one with the fourth issue in your tabs?
The fourth one, you mean this one?
The last one, yeah.
Yep, totally.
All right, are we going with that one?
Yep, go for it.
No one's objecting, yeah.
Okay, cool. So this proposal comes after a lot of feedback we've received from the ASP.NET Core team. Effectively, as they have been trying to get ASP.NET Core work in native AOT applications, they've had a few challenges when it comes to consuming system.text.json APIs, and especially when it comes to the semantics of JSON serializer options instances that haven't been explicitly configured by the user. There's a bit of awkwardness to be handled there, and it needs to be handled in a way that doesn't involve routing the entire reflection-based implementation, which can be pretty large. And the way that essentially the ASP.NET Core team solved this in Preview 1 was that they actually implemented a feature flag on their layer as an app context switch. And that particular app context switch is recognized by the trimmer, and it essentially lets published applications to treat that app context switch as a constant, and trim code at publish time while the user is consuming the exact same APIs. Their feedback is that they would like to see this. They implemented this feature flag in their layer, but they would like to see this being moved to the system.text.json layer, which I think makes sense. So this is essentially a proposal to introduce a new feature flag. I'm calling it system.text.json.serialization.disable default reflection. And when you enable that, it essentially undoes the default behavior that system.text.json has always had when it comes to its default settings, as in opting into reflection-based serialization. But that has a couple of ramifications. It essentially means that we are now using the default constructor in JSON serializer options to eagerly populate the reflection resolver, which means that the constructor would require and reference code and requires dynamic code annotations. I'm not sure if that's necessarily important from the perspective of API review, but I just thought I'd mention it. But we still need to provide a workaround for users to create JSON serializer options instances in a linker-safe way. So effectively, the API component in this proposal is that we add a new JSON serializer options constructor that explicitly accepts an iJSON type info resolver parameter. Now, by having this feature flag, it means that we actually that feature flag changes the semantics of a default JSON serializer options instance, and that means that if it's turned off, it will eagerly populate the instance with reflection. If it's not turned on, it will eagerly populate the JSON serializer options instance with the reflection components. If the flag has been turned on, i.e. disable default reflection has been enabled, then no reflection components will be added to the options instance, and therefore it can be consumed in native AOT in a trim-safe manner. And that has an impact on, for example, the trimmer annotations on the instance methods in JSON serializer options. For example, the getConverter method would now no longer have the requires and reference code and requires dynamic code annotations. I suspect that you might need more context here, but I'm curious what you think with this introduction.
I think so far I'm following along. So one question I have is, given that you move to eager versus lazy, does that have any perf impact on people that don't do linking?
It should not have an impact. It basically, maybe scrolling down to the examples might illuminate what this is actually proposing. But the idea is that if you, the top example shows you the current behavior in .NET 7. When you create a blank JSON serializer options instance, first of all, the type info resolver property evaluates to null. That basically means that we are actually lazily populating that property if we actually pass that options instance into the JSON serializer APIs. And this is the behavior that JSON serializer options has always had since it got shipped. Now, the first thing is that there's no resolver property set in the default instance. And as a result, if you call options.getTypeInfo, you will get a not supported exception, no metadata for a given type, because you haven't configured a resolver. The reason for that is that getTypeInfo needs to be linker safe, and therefore it cannot do lazy population. Now, the JSON serializer options are not linker safe, and they will actually lazily populate type info resolver, and this will serialize successfully using reflection. One thing that I missed is that the post condition after the serialize method is that after that, options.typeinfoResolver would no longer be null because it will have been lazily populated by the serialize method. Oh, I did add that post condition. Sorry about that. Now, essentially what this is proposing is that we introduce the feature flag that essentially bifurcates the semantics into two separate worlds. By default in .NET 8, i.e. when the disable default reflection feature flag is not enabled, the idea is that when you create an options instance with a default constructor, it will have the default JSON type info resolver populated equally. Calling getTypeInfo would be successful, and serializing it as before would also be successful. So you would be getting essentially consistent behavior in both the getTypeInfo and the serialize methods. I wouldn't consider this a breaking change, even though it changes the behavior, because it changes from something that throws into something that succeeds.
Right.
Now, if the feature flag is enabled, then when you create a default instance, type info resolver would be null. If you call getTypeInfo, you would get not supported exception, but also if you serialize, you still get not supported exception. As in, with this disabled, the lazy population thing is effectively turned off, and it effectively means that if you've been disabling it, it means that you wouldn't be accidentally routing all the reflection-based converters in system.text.json.
So
and the transitive types that these depend on.
So calling the constructor on the default JSON type info resolver, like, is it just instantiating the type, or is it doing some like reflection lookup, scaling assemblies, adding things to dictionaries?
When you just create an options instance.
Well, basically, like when you like in the current behavior, right? When you basically lazily instantiate this thing, like how much work is this lazy instantiation doing? Like, are we just doing it lazily because we could, or did we do it for perf reasons and now we're basically doing it eagerly, so now everybody pays for this whether you use it or not?
Well, the only reason, so there's no perf concern here. The reason why it's been doing it that way is that when this thing got shipped, reflection was the only thing that it could do. So the idea was that, you know, there wasn't a type info resolver as such. You were passing it an options instance and it would, you know, do reflection-based resolution. Now, in order to not break the default scenario, we needed in .NET 6 to make the lazy population thing work, i.e., if you're passing a JSON serializer options instance that didn't have a source-generated context, then it would say, aha, this is a JSON serializer options that has been configured using kind of the legacy thing, and therefore I anticipate that users would want reflection. So that's how we kind of very accidentally ended up with that behavior. We still want to preserve that behavior by default because we expect that most users would still be using that. But the idea is with the flag, we can kind of fearlessly move into the new world that we would have liked to have shipped from day one, assuming that we had implemented everything in one iteration.
So are you saying then in .NET 8 there's like 3 states not configured off and on, or are you saying like the new state by default is basically what off would look like?
Basically, it's
Okay.
2 states, and the default would be well the second block in
Right.
that list.
That makes sense. And so there's some behavior today, right, where if I serialize and then I modify stuff later, the serializer options will throw an exception, right? Is any of this tied to the property type info resolver being null? Like, is it basically a case where because you now do it eagerly, it's immediately locked upon creation, or there's no such case?
No.
Okay.
So obviously, a side effect of that is that we now necessarily need to annotate the default constructor with requires and reference code and requires dynamic code. And this is essential because if you're, for example, writing a library that consumes system text JSON, you might not actually know what the value of the feature flag would be like at publish time. So we absolutely need to emit a warning if the user calls into the default constructor when they're building a library. And for that, this is what necessitates the introduction of an additional constructor overload that accepts the type info resolver. That would basically be without any annotations, but it would require the user to explicitly pass in the resolver that they would like to see used for that instance. And for what it's worth, the source generator would be making use of that constructor overload if this feature gets shipped.
So like, but that would be a breaking change, right?
People will get warnings, yes, but if you're not doing reflection stuff in native AOT, these would be mostly false positives. I wouldn't be too concerned about that because all the JSON serializer methods that accept JSON serializer options are also similarly virally annotated with requires and reference code and requires dynamic code. So one way or another, users are getting warnings when they deal with JSON serializer options.
But presumably when I set this disable default reflection to true, that also suppresses the warnings, right? Or is this completely disjointed?
Well, unfortunately, the trimmer doesn't support having conditional annotations, let's say. I've picked up that people might be working on something like that, but it's not immediately in the cards. If something like that does turn up, so essentially you have a conditional requires and reference code that is predicated on a specific feature flag, then maybe we might be able to have this emit only if the feature flag is not specifically turned on.
Right.
But for now, we just need it's just dumb. Like if you have a static dependency on it, it will emit a warning. It's going to be a false positive, but.
So then I guess the expectation is users that get linker warnings that if they are false positives, they suppress it at the call side?
Correct. Levi?
Yeah, so given that this is meant for linker scenarios, do we also need a way for app developers to discover if this feature flag is enabled so that they can kind of avoid their own calls into things that would make linking difficult? Or
Yeah,
has that already been addressed?
And ASP.NET Core would be the first ones to do that. So they would be relying on the value of that flag to make their own kind of to implement their own kind of logic in the background. And the idea is that there again, the linker would recognize that as a constant and trim away the relevant code.
Right, but I don't see an API in here to get the value of that flag unless they're retrieving it manually somehow.
Well, it's app context, right? So you just ask it.
Yeah, but you're not exposing it through like a first class API. Just tell people go to app context.
Yeah.
Okay.
I think that's generally how app context works. Right? We just document the strings, and you just have to know the string literal.
Okay.
Yeah.
Sounds good.
You'd want two you'd want to check the app context, but then you'd also want like the linker substitution XML file as well to turn your Boolean. So that way that code gets trimmed. So there is value here if we would expose the Boolean ourselves as a public API. I don't know how many people outside of ASP.NET would need it. So I'm borderline on whether I think we should have it or not.
So you lost me at the XML file. So what would the logic then entail? It checks both the app context switch and what else?
So it's not code in your C# file that you'd need. Like, there is code in your C# file. You'd need the app context switch check. But then in order for your code to actually be trimmed away when the Boolean is set or not by the trimmer, you need to have an XML file that basically maps this flag to your code to say, when this flag's on, this property should always return true or always return false.
I have a question. If we were to expose the flag as a .NET property, would there be a mechanism that users could just check that property so that they don't need to do the accompanying XML configuration?
Yeah, if we expose the property ourselves as a public API in system text JSON, then that's the thing that would get, turned to always true or always false by the linker, the trimmer. And then upstack code wouldn't need either the app context or the XML file. They just check the API.
Yeah, I think there would be value in us adding that, but do you think we should iterate on this, or should we consider a design that incorporates a property?
I mean, this might be a dumb thing, but like if I write naive code that basically just says, I don't know, app context dot get value with the literal, are you saying the linker doesn't know that this is a fixed value that will be false?
Correct.
Aye. Wouldn't that be the better fix? Enlightening the linker. I mean, if the linker is already aware that this thing exists, like why can't the linker now, if you call this API with this key, the return value is a constant and can then trim the resulting IL from that?
I don't think the substitution file, so someone might have to correct me, but I don't think the substitution file has rich enough semantics to convey that. The way that we normally do this in all other project types is that we have an internal helper method that is special cased by the linker to always return true or always return false. Because the method literally takes no parameters, it just returns a Boolean.
I mean, in general, we don't necessarily tell many people to check our own app context settings, right?
Yeah, I was about to say that if we generally expect that app context is an ugly thing that only the framework uses, then I think it makes sense to say, well, if you want users to do it, you expose your own public API that has a proper configuration, which seems like is what we are saying here as well. In which case, it would be, I don't know, a static property on JSON serializer options, right?
Something around there, yeah.
So should we try shipping the feature flag for now and investigate whether exposing it as a property later might be valuable? I'm not necessarily convinced that it is at this point. I would need to do a bit of experimentation on my own.
I mean, I'd be fine with iterating on it. Like,
okay.
Emo, you seem to have the most.
No, I mean, I was just trying to understand what the semantics are. So if we say we believe that people want to write code that basically checks for this, then I think it would be very unfortunate if we tell them, first of all, you have to know this magic string that is not entirely short, right? Then you also need to add some XML configuration so that you can actually make sure stuff gets linked out. That seems like a pit of failure, right? So, but if we are saying we're not convinced that customers need to do that, I think I'm fine with deferring that. I would just say if we believe that people want to do that, then we should have an API for that.
Agreed. I agree with that.
Okay.
And I assume the only party that we know we would need to do something is ASP.NET, and they can do the hard thing.
For now, yes. I'm not 100% sure we have to do it. We haven't prototyped this whole thing through the whole stack yet. It's kind of like an option if we think we need to check this flag in ASP.NET and do different things.
But you do have this flag already in the ASP.NET Core layer, so
yeah, we have it right.
Yeah.
We have it ourselves. Like the one, our reason we would maybe want it is because that first constructor is going to warn, right? And that's the one we want when we're in normal core CLR mode. We want that default constructor. So our options are call that default constructor and then suppress it, the warning, kind of like the false positive case, right? Or we check this flag, and then when the flag is set, we don't call the default constructor, we call the new one, so we don't get the warning.
I'll point out that in scenario where these warnings kind of make sense that they appear, these are the types of scenario that you would typically use SourceGen, and in the SourceGen APIs, you never need to create your own JSON serializer options instance. Generally speaking, the source generator builds an instance for you, and you consume that. So this primarily concerns either advanced scenario or doing reflection-based serialization, or in the case of ASP.NET Core, you need to be able to write infrastructure that hands over a JSON serializer options instance to the user via a callback, and they want ASP.NET Core want this callback to have the same behavior regardless of whether you are running it in native AOT or whether you are running it in core CLR. And the idea behind the feature flag is precisely that. By inserting this bifurcation, you basically are saying that JSON serializer options will just work with the expected behavior in either of two worlds, rather than it working unexpectedly in both of them.
Because you basically move the penalty towards the party constructing and not the use side.
Correct. Yes.
I think that makes sense to me. I still find it I haven't played with the linker, but it still seems sad that we have the model of like, yep, you always get false positives and you have to suppress in the right places, but that seems to be the model. So.
But like I said, we might be able to get to a point where these annotations are conditional in one way, and that might remove a lot of the noise.
My hope is for the 90% of developers, especially app developers, they'll never have to suppress warnings.
Yeah, that would be ideal. I think the unfortunate thing with JSON is that we basically live in this bifurcated world, right, where source-generated JSON and reflection-based JSON is just different APIs. So people have to do some amount of work to get there, right?
Yeah.
But that's, again, this is a... we are trying to make source generation easier with C#, but we're not there yet, so... So that seems reasonable. Then, sorry, what was that?
To libraries, is there a cost or complication to libraries for moving the attribute?
Yes, but like in a good way, because sort of in a good way, because if you're a library and you claim that you're trimmable, and you say new JSON serializer options and try to use it. Expect like coupled with other changes that we're making as well, right? Like the Git type info, like that stuff will work today using reflection, and you won't get any warnings. But you're relying on reflection.
So are you saying that like I can build my library by basically saying like, okay, please make sure that I'm trimmer friendly, and then I just build a DLL that is basically not AOT'd or anything like that, but then you give me still the warnings when I do something wrong? Or do I have to actually build an app, enable linking for that app in order to get the linker warnings?
The plan is if you're a library, to get the linker warnings, you turn on is trimmable on your library, and you should get all the warnings that tell you here are the places that are going to fail.
Gotcha.
Or potentially fail.
But that doesn't exist yet. You're saying that's something we would ship for 8.
No, we've
that-
been doing that since 6.0.
Okay, so people can already do that. So if somebody might have done that, and then by us moving the attribute, yeah, same argument, right? You just get the warning in the right place now, or I guess in a better place now.
Right. I mean, it's a little bit more of like, because you've moved it for 8, somebody who's building a library targeting 7, like, are things going to go poorly for them? And yeah, I don't know. Moving attributes sometimes messes up models. I don't know the questions to ask here, and I'm really asking, are we doing this in a way that won't work for libraries? Or are we doing it in a way that requires complicated things for libraries? Because if we think trimming is only relevant to apps and we don't care about libraries at all, which doesn't make sense, then it's fine. But it seems like there's maybe a hole in the app story, and I'm trying to understand if from an API evolution perspective, we need to say changes like this are prohibited, and the runtime changes that would be associated with it are also prohibited. I'm trying to understand the model.
I mean, that's I guess a good question. Is like, given that system text or JSON builds for net standard 2, like are you attributing these? Like, are you if-defing these attribute changes to 8 only, or are you saying everybody that targets net standard 2 will also see those attributes being moved?
I believe every target receives these attributes.
So if I'm building for net standard 2 and I claim I'm linker friendly, I will also get the right warnings and the right, like the new kind of experience. Okay.
If you update to the newest package version.
Yeah. Like that's the.
So the thing is you can't. That's the whole today in the trimming story is the net standard 2.0, like the core libraries aren't annotated in net standard 2.0 for trimmer annotations, right?
Sure, that's
so
the same with nullability. Yeah, basically, system text or JSON itself is, but then the framework itself isn't. Yeah.
Right, exactly.
Sure.
You would actually need to target 6.0 or higher in order to get the analyzer to work correctly everywhere.
Yeah, I see. Well, yeah.
It's actually a struggle I'm having right now with multiple libraries that
I think
I'm trying to annotate.
That is one argument that I've heard in the past is like I could see us shipping a new version of net standard that only adds annotations if we really cared enough, right? Because we have this with nullability, we have it now with linker, and that might be a reason to do it. But yeah, that's not specific to system text or JSON. That's the general problem of like targeting multiple framework versions. And but I think I like the model that you're saying we do the same API surface for everyone with system text or JSON because it's logically in OOP everywhere. It's just there's some inbox version in core that we ship, but you can always depend on the latest version. I think that would make sense to me. Can you explain the JSON serializer thing at the bottom where you say annotations preserved? So basically there's no changes. Is that what you're saying?
Yeah. Initially, I was very happy with this because I was like, yes, finally, we can remove all the annotations in JSON serializer. But the problem is, if you look at the signature of the serialize method, the options parameter is optional, which basically means if you don't pass anything, well, of course, it's going to use reflection.
Right.
So unfortunately, it can never be removed from these methods, which sucks because there's nothing fundamental about these methods that are forcing us these annotations. It's just backward compatibility. I'm linking to an issue at the bottom, which is essentially a proposal to eventually add instance methods to JSON serializer and essentially pushing all these trimmability and native AOT concerns to, well, serializer instance constructors. And once you have an instance, then there's no annotations in the instance serialization methods, but that's probably a proposal for another release.
Couldn't you do the thing where you just basically add an overload that doesn't take the options, and then on this one make it basically no longer optional, and then basically you could say this new, like basically the existing one would no longer have the attribute because people that have just the source code they're passing in, I guess if they're passing in null, they would now get a warning, right? Yeah.
You could, but code that has been compiled against this method would not get updated unless recompiled. So
that's true.
But then again, they won't get the warnings either.
Yeah, that's true. Yeah, it is what it is. All right, then I think the only note that I have is that we may want to add an API or not, depending on where we want to go with this, but otherwise.
I had another thing that might be worth bringing up. If you notice, you'll see that the IJSON type info resolver parameter in the constructor is nullable, and that essentially means that if you do new JSON serializer options open params null, you would get different behavior compared to new JSON serializer options no parameter. That's intentional, but I'm kind of wondering if people might object to that inconsistency.
So what is the reason to make it nullable?
Well, for one, the source generator would need to be able to pass a null JSON type info resolver. I'm guessing that that's not reason enough. I suppose we could always mark it as non-nullable and force a null in the case of source generated code, but
because you don't want
passing
this.
null do?
Say again?
What will passing null do?
It will populate the type info resolver property with null, which is unlike the default constructor, which, depending on the value of the feature flag, will either choose to leave it as null or populate it with a reflection resolver. But in the case of the new constructor, passing null will unambiguously give it a value null.
Right. And presumably you don't want the source generator to call the default parameter, the default constructor, because, well,
I mean, I could just suppress it because I know for a fact that it won't cause any issues. But, well, actually scratch that, because if you're using source gen and you're calling the default constructor and the user is not enabling the feature flag, then you'd be accidentally routing all reflections. So no, that's not feasible, even with a suppression.
I mean, I'm kind of inclined to take it as you described, because, I mean, maybe that's the wrong model, but I feel like every hack we do in the source generator is kind of unfortunate because it is user code at the end of the day that they can debug through, right? So the more ugly that gets, we still kind of expose it to the user.
Yeah.
At which point I'd more inclined to say, well, there's documentation for the API, we document how it behaves, and, you know, it's fine.
Yeah, I mean, while there's sort of a general-ish option or notion that the longer overload passing default should be sort of-ish, kind of-ish the default, I think in this case the model is the default constructor cascades to this one using whatever app context says to, which is either the reflection resolver or the null resolver. And so I think we can explain that story.
Yeah,
so,
that's also a good point.
If it was going to do something different than either, like if passing null would do something different than the default constructor would do with the app context switch in either position, then I'd be like, okay, no, like you're off in the weeds now. But if it's the same as the default constructor when the context switch says don't do reflection, then that seems okay to me. Can somebody instantiate the reflection resolver if they want to?
Of course they can.
Okay, I didn't know if it was non-instantiable or non-accessible or.
Yeah, it is possible, but then they'd be getting warnings in that instantiation as well, obviously.
Sure, but going back to the API point, it's the default constructor uses the app context switch to pass null or new default resolver. Somebody could do that themselves using this other public constructor, so nullable seems fine.
Yeah.
All right. Yeah, it's not ideal, but it's, I think, the best we can bring given backward compatibility constraints.
I would agree with that. So then,
Thank you.
This one is kind of, you don't have to do it now? Is that what you're saying, or?
It's not super high priority, so if somebody else has something important, then I'm fine with that.
All right, then let's move this to the end and see what the other ones are like. Who wants to talk about this one?
Yeah, I can talk about this one. Okay, so this is basically we are introducing an abstractions for the system time. This is a long requested feature that the community and users requested for many years now. And the benefit of having this proposal is if you look at users code or our even .NET code, you will find like many places is defining their own interfaces like iSystem clock or something similar to that. And this is defined like tons of times and everywhere, and it's not consistent and it's not usable. I mean, like outside the scenarios that they are defining it. And second thing is like these abstractions, when you have it, it will allow mocking scenarios. I mean, like if somebody need to test their functionality that it depends on the system time, for example, I know they can use these abstractions to mock the scenario and to have more control on the tests. The idea here is for this proposal is we need to have this also work for the cloud native scenarios, which is required to run on the down levels, I mean, including .NET framework. So we are thinking about this abstracts is going to be in .NET 8. It will be defined inside system runtime, I mean, the core lib. And for down level, we are going to have the implementation for this for down level in some OOP. We didn't decide yet exactly which library is going to land on, but I was thinking about like Microsoft Extensions primitive is one candidate, but we need to see about like if this is a good place or should we have it in another library, because like I hear like there's more features requested to run on down levels, I mean, and we need to support it also. So maybe we can figure out another library that it can land this implementation for down levels. Yeah, so any questions so far before we go to the proposal itself?
Well, the only thing I would say is I would focus on the API and ignore the OOP for now, because I mean, that's kind of an orthogonal issue, right?
Yes.
I mean, they're all standalone types, so we can always put them somewhere.
That's not 100% true. The main abstraction, that's true, but part of this proposal includes passing this to existing types. So, you know, new overloads on task, for example, and those we can't OOP. So if we want to do something there, we'll have to create extension methods in some cases or some other replacements in some places to put those extensions.
Right.
Yeah, I mean, yeah, so that to me is kind of like a, yeah, the reason I would decouple them is because they're kind of like just the physics are, right? They don't really impact the naming, right? Which namespace you put it in, right? That's what I'm trying to get at.
For this core thing, that's correct.
Yeah.
Yeah.
And then the shape of the time provider also wouldn't depend on OOP versus non-OOP, right? I mean, we need an abstraction, and then, yeah, we need to touch other APIs and provide some glue. So maybe there's some additional APIs we need to review, like the extension methods, whatever we want to do for those. But that wouldn't necessarily impact this review here, right?
I mean,
It doesn't
then if it took parameters that were object types that didn't exist in that standard.
Yeah, it doesn't affect time provider itself, but later on, if you scroll down, there are places that it would affect.
Yeah, that's fair.
Yes.
So then I guess we should start with the time provider one.
Yeah, so this is actually the abstraction, the main abstraction that it's abstracting the system time in general. So as you see about like we made it as abstract class. This is mostly to be allowed to expand it in the future if we need to. I mean, because like part of it, we need to have it to be supported in the down levels. So basically time provider is abstracting UTC now, local now, and the local time zone and get timestamp and the timer. So this is the 5 things that it's abstracting it. If we go, I mean, like one by one from the top, I mean, like we have the protected constructors. This is just if anybody want to subclass this abstract class, so they will be able to use this constructor. The second, the property system, this is actually is going to provide an instance of the implementation of the time provider that match the system behavior exactly.
Right.
So like if you call like system.utc now, it's exactly like datetime offset dot UTC now, for example. Yeah.
Right.
Yeah. The second, the next one is a static method, which is you can create a time provider and passing a different time zone. I mean, like, so by default, when you create the system, we use the local time zone, which is internally. But if somebody want to create a time provider and using a different time zone, so they can use this static method to create the time provider with this specific time zone. Yeah. Next one is just the abstraction for UTC now. It just returns datetime offset. It's exactly like datetime offset.utc now. And the next one is local now, which is it returns the local time. This is dependent on the time zones that inside the time provider. So this is basically take UTC now and take the time zone and convert it to the local time and return this result from this property. Yeah. Next one, next property is a local time zone. If somebody want to customize or use, to override the time zone on the time provider, they can do that. Can you scroll down a little bit? Yeah, next it's timestamp, which is returning the timestamp. This can be used for the perf scenario measure, benchmarks or something like this. And also we have the timestamp frequency, which is returning the frequency for this timestamp. The frequency is like, the value returned from the timestamp. It can be divided by this frequency to get the number of seconds, measured by this timestamp. And we have a helper method, which is get elapsed time, which can be used. It's just a helper method about like to calculate exactly like the time span from using the measure two checkpoints. Getting two time stamps, and we want to measure the time span between them.
So I need to ask, so to me, the UTC now and the local time zone makes sense. You just abstract the time, and datetime offset doesn't have the time zone itself, so that makes sense. But like, I don't understand the time zone frequency. What is it that you're abstracting here?
Yeah, the frequency that you are measuring the timestamp with. This frequency can change. Like if you want to customize about like, how you're getting the timestamp and what kind of frequency, because like timestamp itself without the frequency, you cannot know exactly about like how this measure to the actual time, like second, minutes, or whatever.
So
a time span has a well-known frequency of 100 nanosecond, whatever rate. This varies based on the hardware environment.
For example, on .NET Framework, depending on how things were configured, stopwatch.frequency would return different values. And that also impacted then the kinds of timestamps that it gave you back. So timestamp by itself is a completely opaque value. You need the frequency to understand what it means.
I see. And then, so why is it abstract? Shouldn't that be maybe defaulted to whatever the system provider normally does, or no?
No, for customizing, anybody want to write their own marking, like for the time provider, they need to control that. The timestamp and the frequency for it.
Yeah, I'm not saying they shouldn't. I'm just saying like, should it be virtual rather than abstract? Because it makes sense to me when I'm mocking something, I just care about the time, and I just would say, well, whatever the granularity is that the normal datetime thing provides me is fine.
So the model here is there's a system, there's a static that represents the system, the real world time provider.
Right.
So you're not deriving, if you decide not to be in the real world, you have to implement the virtual world completely.
I think, Imo, if I could rephrase your question, I think your question is basically, if I'm just if I'm just mocking this, maybe I don't care what the frequency is. I just return timestamp 1 and timestamp 2, and the frequency doesn't matter. Is that what you're saying?
Yeah, I mean, I would assume that when you mock something, you just have a fixed time, let's say. I would always return the same value, right? And then would I really... Because now you force me to override all 3, right? And I'm just... Actually, all 4,
No,
right?
that's not how most mocking frameworks work. Most mocking frameworks only require you to override the very specific things you care about. And everything else, if they're called, turn into not implement an exception.
Yeah, but here you wouldn't be able to compile unless you override it.
But
Right.
but that's not necessarily the scenario that people who use mocking frameworks find themselves in. If we're building a type specifically for DI and mocking frameworks, like, we should understand how people use mocking frameworks.
I mean,
Even with that, Levi, this would be problematic because getElapsed time needs to access timestamp frequency. So
Oh yes, it absolutely does. Yeah. What the reason I had raised my hand is I was asking just to make sure, like, for any given instance of this class, timestamp frequency should be fixed, correct?
yes,
Okay.
it would
Just
be
checking.
a read-only const if you could make that abstract.
Yes. Okay.
Right.
Because is local time zone also supposed to be fixed for any given instance of the class?
Yes.
So-
Because that
Sorry,
is a bit
we-
weird because of the system.
No. Yeah. The system one will not be guaranteed because, like, people can change the... Okay, the system time provider is going to use time zone info.local value, which is, it's fixed till if somebody changes the time zone on this machine, and after that they clear the cache for time zone, and this can change it for the system.
Right. I think the short answer is actually no. This is not guaranteed to be fixed.
Yeah, for the system one, yes.
No, for
So
any of them.
You can make the timestamp frequency be forced to be implemented as a const by the property is non-virtual, and you make a protected get timestamp frequency member that is literally only called once.
That makes it very difficult to
We're
mock.
talking about two different things. The conversation briefly shifted to local time zone, and I just
Yeah.
want to be clear that the answer is no. It is not guaranteed to be fixed, especially if part of the purpose of this is so that people can test how their code works when it will actually be running on real world systems. And so code will need to be able to deal with the fact that local time zone can change on a real system if you're using time zone info.local today. And so saying that this shouldn't change other than for system doesn't really make sense in the context of something that's going to be used for mocking.
Yeah,
if it's an
one thing I would
abstraction-
kind of like. Oh, sorry,
Yeah.
go ahead.
No, if it's an abstraction, you don't know whether it's system baked or not, right? So you have to assume any
Yeah.
instance could change, right?
Whereas timestamp frequency, I think we should be able to say this will never change. And if we want to make this, if we want to guarantee that, we do what Jeremy was saying, which is basically we make this public long timestamp frequency, not abstract, that delegates to a timestamp frequency core, whatever, and timestamp frequency will only access that core thing once.
Right.
I'm going to push back really, really, really hard against that, because if we're making something specifically for DI mocking scenarios, we've killed the ability to mock it at that point.
How so?
Because most mocking frameworks, like the really big mocking framework in .NET is MockU.
Yeah.
And calling constructors and passing things down to constructors is possible in that framework, but is such a bizarre thing that most people don't do.
This
The
isn't passing
overwhelming,
anything to a constructor.
it's calling a protected member.
Yeah, rather than having a
That's-
public abstract, have
That's
a public non-abstract and a protected abstract.
that also becomes very difficult in the mocking framework. Like, the mocking frameworks really, really want public
No,
abstract methods.
I don't think we care about making a mock auto-gen tool work. We care about letting someone define a type that does whatever they want. So
But
this is
they're
type
doing it-
extension.
They're doing it because they want to be able to mock it, though.
No, they want to be able to DI it.
But you're DIing it because you want to be able to mock it inside of a unit test.
Well, I
Mock
mean-
just means you're not using the real one. It doesn't mean that you care that you're using the library named DemoQ.
Well,
Yes, but I think we need to accept the fact that that's what the majority of .NET developers do.
I mean, let's go back for. I mean, my understanding is that like the project we are leveraging this type from has some notion of, like, you call it fakes, I think, Martin, right? So, like, is there going to be a fake for this, or that we expect people to extend, or is this basically everybody's on their own, they have to extend the class by hand?
So my expectation is that we would publish a time provider fake, which implements this whole interface and is designed to be used from a unit test. So it has mechanisms to let you manually advance the time, maybe and do all the operations so that you can write deterministic tests.
Right.
So it's not about running AutoMock and these mocking framework. It's about using this dedicated time provider, fake time provider, that encapsulates all these testing behaviors.
But even with mocking, I'd like to understand this better, because last I used mock, like there was a mock.protected or something that was dedicated to making it easy to mock protected members. So what am I missing? What's not easy about protected abstracts with mocking?
It's possible, definitely. It's just it doesn't follow the same groove that most people get into when they use these frameworks. Because at this point now you have to go into, okay, let me go find the member using reflection. Let me start typing all these things in order to make sure that I'm finding the correct overload. Whereas if you're using like the public API surface, in that framework, for instance, it's just very simple link expressions. And it just reads very naturally, very fluidly. And we would be basically saying, no, you can't do that anymore.
I mean, I think we'd basically be saying we use the patterns that we use everywhere else. We use kind of these core abstracts where you're wrapping some functionality around it, whether it's argument validation or caching or whatever. And we're following.
I don't think that's a good argument though, because we have to. I think we're actually talking about two completely different worlds here. One world is we're making an actual abstraction like Stream that we expect people to have lots of different implementations around. And the other world is we expect people to use this within a unit test and pretty much nowhere else. And I think this type that we're talking about right now is in that second world. Like no one's ever going to create this thing except for a unit test. Like my actual web service application would never create one of these things. Like why would it?
No, there is some scenarios for the web requests. For example, I mean, like they want to make it work with different time zones according to the requests they are getting. So I'm expecting like, they will have like time provider and just set the time zone on it and get whatever local time or whatever, I mean, automatically instead of.
So that says you need a different model then. You need to be able to derive from the system time provider and override some of its behaviors.
Yes. Yeah.
What that tells me is that the only API that I really want is get local time for that scenario. And that this type that we're considering right now is not appropriate for the scenario you just mentioned.
Why?
Because this type is kind of like the kitchen sink and everything else, whereas what was just described is like, all I really want is a way to easily get times linked to a certain time zone.
No, that's one very thin slice of the set of scenarios. That's not the reason this whole type exists. That is one of the scenarios for this type, not all of the scenarios for this type.
But that is basically like you just call the static method, right? You don't have to derive the type or anything like that, right?
Yes, but there's already a one line of code, thing in .NET that can do that for you. So why would we tell people use this thing instead of the one liner that already gives you that?
Yeah,
it's replaceable in tests. So you want deterministic behavior in tests, and relying on system clocks that change does not lead to deterministic tests.
So
right.
My understanding is that basically if you write production code where you basically wire things together, people would never extend the type. It would basically say time provider.system, that's what they pass in at some point, or maybe it's auto-populated by DI. And then there's other cases where you want the system time of a different time zone where you use the method. So that's basically what you do in production code. And then the entire extensibility model is only for testing. So you don't expect people to do that on the production side, if that makes sense.
Right. So these, I guess the thing that I'm coming back to is like the scenario that was just mentioned. Like I have a web application and it's running in some custom time zone. Maybe it's per user, and I want to be able to get times within that time zone. Like I said, there is already a one line of code thing in .NET that you can do today to get that. Like, how does this add value to that specific scenario?
Well, you implement all of your code in terms of this.
Yeah.
And then when you're testing it, You supply it with the thing that enables it to be tested. But your code is written in terms of this, your entire application in terms of this.
Yeah.
Why?
So that you can test it.
So the point is, you replace uses of static methods, and you go through an indirection instead, so that you can replace these indirections in your tests.
Yes. I'm well aware of the whole concept of DI and mocking and everything else. I'm just saying, like, this seems awfully heavyweight for this seems A, heavyweight, and B, like we're trying to apply normal like .NET breaking change and longevity rules to something that customers have to a scenario where customers tend not to care about stuff like that. And it's making me really nervous that we're not setting ourselves up for long-term success here. Or that we're trying to get people to use a complicated system for a relatively simple scenario.
I don't think that's true, because it's not just about you write some test code and you throw it away. It's that your long-term, long-standing application needs to be written in a way that makes it testable. Your long-standing application, you don't want to churn it. You don't want to have breaking changes throughout it. You need something that you can use everywhere you create a timer, everywhere you create a task, task.delay, everywhere you say task.wait async, everywhere you get the current time, everywhere you check the time zone. You want to be able to have a very stable, excuse me, API that you're doing with that. And in production, you're always passing in timeprovider.system into the kind of the core funnel, right?
Correct. Yes.
But when you're testing certain pieces of it, you're passing in something else. And you're not going to rewrite your application for the tests.
Correct. I'm to be honest, like I don't need mocking explained to me.
Like, I'm not trying to explain. I guess what I'm wondering is, what do you mean you think this is too heavyweight for the scenario? That is the scenario.
I think I can already have written today something that encapsulates the scenario of I want to be able to get a time and to modify it such that it fits a particular time zone. Like, that scenario is, again, already possible today. But
this scenario is not abstracted.
It's not, and that's
in a very specific way, but it's not abstracted that can be used across the app, right?
What I'm trying to figure out is whether we're trying to make an actual honest-to-God abstraction for people to subclass and change the behavior of, or whether we're trying to make something that is mockable. Because I think those two scenarios are actually very different and require different like API attacks.
Let me ask you a different question, Levi. How would you change what's on the screen right now if you believe if it's the latter case?
The latter case interface, not abstract base class interface. Like, that's what people use for DI. For one.
Sorry, what was it?
An interface for one. Like, people use interfaces for DI instead of abstract base classes. Like,
so that's your objection, is the interface versus abstract?
It's not the objection, but I think it's an indication that we're approaching this from the wrong angle.
Okay, putting that one aside, what's next on your list?
The next thing on the list would be that I think we have a class that's doing too much rather than one thing. Like, if we want a class that is literally just get the time, then there should be an interface which is get the time, and we shouldn't have things like have timers or stopwatches hanging off of it. Like, that should actually be a different interface because it's a different concern.
So I would ask that you go read the issue here, which has spent months and months debating that topic.
The issue that's like 300 posts long.
Yes.
Yes.
Yeah. Which has resolved itself with the foremost naysayers about combining them agreeing that they should be combined.
Okay.
I think the problem is, there's similar concerns in chat about, which is kind of our default answer, is like, people should build their own abstractions, right? I think what we find though is that time is such a viral concept that is something that everybody wants to kind of abstract, but so that kind of leads itself to this point where we want to provide something in, in a way where it's like default by configure, like is configured by default. It's in DI registered, and then the rest of our like infrastructure can talk to that thing, so people don't have to do the heavy lifting all the time, right? Which isn't ideal, I guess, but at the same time, that's another reason why I kind of like having an abstract class over an interface, because it means we can evolve it, right? So we can. There's this other area in the VCL where we really want to integrate it with the time provider stuff. And so we can add another method like create timer on it, right? And yeah, we probably have to now make the default implementation throw not supported or something, but like, we can at least evolve it and make it the, as you call it, the honest to God abstraction to how to access time, right? In a way that makes sense.
And I think that, raises the next philosophical question, which is, do we actually want to be able to flow these things within the BCL? It sounds like the answer is yes, because most of the time when you're talking about an abstraction interface, DI, whatever, it actually can exist as something completely separate. And the static implementation, for lack of a better term, also ships as part of that same OOB package. It sounds like with this, and I just want to make sure we're clear on this, it sounds like we're saying we actually want an honest to God abstraction within the framework because we want to be able to rely on it from other places within the framework, rather than having it as something that is just tacked on.
Yes, it started as the tacked on thing and it evolved into the core types within the runtime rely on this.
Okay, got it. Which is different than how DI and mocking normally works.
Well, I mean, to
yes.
me, DI solves the, basically it solves the how do you get the instance, right? But it doesn't solve the, what are the places that take one of those, right? That's a decision that is almost orthogonal. It's kind of like cancellation token, right? It doesn't really make sense to put it in DI, but we have lots of methods that take one, right? And so that will be the same here, or like culture info, right? Logically, you could imagine culture info being DI injected, right? But like we have a bunch of APIs that take a culture info. And so I think that's kind of, I think the BCL concern is like which places should take one. And then the high level concern is like, how do you get one, right? And that's basically where DI would help.
Yeah, that's actually kind of a funny example because in .NET Core, we un-DI'd that type and said we're the only people that can ever make instantiations of it. And it's now no longer possible to make your own. So we actually killed the constructor on it.
So which constructor are you talking about?
Culture info.
Yeah. Well, I think culture info is kind of similar in the sense that you don't want to necessarily create a culture out of thin air, but you want to swap it out for testing reasons or other.
Oh, yeah.
Yeah.
Well, we also allow you to, even if you can't construct it with a constructor, we allow you to create them and populate them in other ways. Like I can get a culture for any culture I want. I can then walk up to it, clone it, populate it with date time formats and whatever I want. Just because there's no constructor doesn't mean I can't create it.
Right. It's an object model at that point, though, rather than like something that's really mockable or DIable. But yeah.
Well, it's still DIable. It's just not mocking the standard frameworks.
And still the constructor is still there. I mean, like if any user want to create culture info with the constructor, they can do that. I mean, nothing prevents them from doing it.
I think Levi's point is more like what people like expect from an API shape, right? And I mean it's true that people that do DI, they like their interfaces because it's not tying them to anything, right? But I think that's to some extent that is a flavor or an opinion, right? That's not necessarily a correctness statement, right? And I think for us the problem really is an time provider would be harder to evolve than a time provider, right? And I think we care about that you can create something in testing, but there's really nothing saying that it has to be done by a mocking framework, right? I think it's completely fine to say we ship another type called fake time provider that we optimize for this scenario and that has helper methods to advance time, subtract time, whatever, right? And then that's what we expect people to use in testing, right? I think the scenarios we make it swappable, but we don't necessarily have to say, oh, it has to be via this mocking framework that does everything via link, for example, right? That's just one way to do it. But for the same reason why we don't like interfaces, that might not be the one that we want to ship because it's harder for us to evolve.
Sure, yeah, and if we're talking about right now, we want to introduce a primitive abstraction because we plan on using it in other places in the framework, great. Then that should be our primary thing. But it was making me very nervous that we were talking earlier about changing the API surface in such a way that it would make it less pleasant to consume from typical mocking frameworks.
I mean, that's the other discussion we had, right? I think Stephen had this strong viewpoint that, fakes don't belong in the framework, but that's an example where if we were to put the fake in the platform, well, then we get away with not allowing anybody to construct one, right? We just say there's a system one, and then there's the fake one that you get to new up and that has a certain API shape. And then it doesn't really matter what the abstract API service of the time provider ends up being, right?
Yes.
That's another option we would have, but... Yeah.
So long story short, if you wanted to be pleasant to mock, definitely keep the abstract get frequency, and don't make it a non-virtual getter. I mean, I know that that's better from like a purity perspective of the API, but it does make mocking less pleasant, definitely.
Better from both the purity of the API as well as, I'm not sure perf is the critical factor here, but it'll be faster for something like the time provider to, for the system provider rather, to make it just an inlineable method that reads a field rather than an abstract call, virtual call on every dispatch.
Yeah, I mean, my opinion is if we think that we need the abstraction for whatever reason, we should design the type correctly. And we should not say we're designing it to be easy to use with mock or any other specific tool. It's we design it. If it's going in system, it should be designed per the rules we would design anything else in system. That's the bar that we should hold it to.
I agree with that bar, but maybe there's also a middle ground. Like,
well, I just mean we have two reasons that we think that the protected core of give me the value once is the right answer, and the one for mocking is the one that says maybe it's the wrong answer. And I think that it's not that it gets 0 weight, but it gets less than 1 weight.
But for example, imagine we combined that with Emo's question earlier about, well, should this thing be virtual rather than abstract? Like one of the things we considered, and we're pretty close to bringing to API review, was basically everything is virtual rather than abstract, and you only override the things that you care about for testing purposes. So like you could imagine that protected core being virtual, and it just returns, the base implementation just returns stopwatch.frequency. And if you care about, for your mocked thing, well, then you go through the dance of whatever you need to do to not use link to do the protected override. But if all you care about is some of the other stuff, you don't need to do that. Right. I like that.
Yeah, I think that's fine. I mean, abstract abstract methods are a thing you only get to use once. And so I have no personal care between the base class is the system time provider. It just doesn't straight up admit that. Versus everything is abstract in V1, and then as you add methods, then they have to do virtual throw because of our evolution rules. So I think it would be fine to do really either approach.
Yeah, because that would actually be my next question. Let's say that we didn't have, a frequency or a timestamp and frequency mechanism in V1. How would we add it in V2 without introducing a breaking change? Make it virtual and throw?
We'd make it virtual and either throw or more likely have it return some default, stopwatch.frequency or something.
Mm-hmm.
And then we tell people like, yes, you really do need to override both, not just one.
If you care about those new members that we added, yeah.
It's like equals and get hash code. They really need to be done together.
Yes.
I mean, in a certain way, that's not new, right? That's the general problem of evolving something that is virtual, right? I just don't know what else you would do. Like, it's not that it's ideal. It's just, okay, what else would you do, right?
Well, this is why, generally speaking, you have single type, single concern. And this abstract base class has, it looks like 3 different concerns on it. But I think I've already said my piece there.
I mean, I don't disagree with you, but at the same time, there is value in like saying time-related stuff is one thing people pass around, and most people would never have to implement it, right? Like even the ones that are testing, I would expect them to instantiate something that is dedicated for this, that somebody built, right? Because it's more convenient than, deriving that type by hand every time you want to test it.
Yes.
In which case, the only people that see this extension stuff is us. And
so
whoever builds the fake.
Do we know what functionality might come in a V2 just so that we have like good confidence that the shape of this is okay and extensible?
I would honestly, I have trouble imagining anything. We've basically included in this all the different notions of time that we've had in .NET Framework for the past 20 years, right? You have we have basically a notion of a callback after an elapsed period of time. We have the notion of the current time. We have the notion of a high performance stopwatch, and we have the notion of where are you in the world. I'm not aware of any other time-related core things that we have in .NET, and the fact that we haven't added any more in the last decade or two makes me less likely to think we'll be adding any more in the next decade.
Well, I mean, we did introduce date only and time only, which are, they're maybe not as crucial to the ecosystem as something like date time, but they're, hopefully important enough where people will start using them. But one thing that people keep asking for that we've never done is a concept of, recurrence that is agnostic as to things like time zones. So I want something to occur every Tuesday at 10 a.m., regardless of where in the world I might happen to be, that follows things like daylight saving time, that follows things like I'm moving countries. We've never done it, but it's a request that keeps coming up.
Sure, if we would ever do that, we would imagine adding that to this.
Yep.
I'm not anticipating we're going to do that anytime soon, but yeah.
Yeah, I mean, I would expect like generally like usability improvements, right? Like if there's some properties that are super used off of daytime offset, maybe we want to promote them here as a member, so that people don't have to dot into stuff all the time, right? And these are just minor things that, don't require new virtual members. They just make the type more usable.
I do think this has a viral effect, that once this is in the platform and the core abstractions are using it, there's many layers above that will want to start consuming a time provider and plumbing it through.
Mhm.
So those will have to be discovered over time, I think.
Yeah.
There's also the opposite of that. There are places in the core. I mean, there are hundreds of methods that we have today that take an into milliseconds timeout or a time span. And this proposal is to start small. We've basically taken the few places that are critical: cancellation tokens, constructor, task.delay, task.wait async, and periodic timer. But there are hundreds of others where over time, as need demonstrates, we add a manual reset event slim.wait that has an overload that takes a time provider. I've explicitly asked us to not go overboard and plumb this thing at thousands of new overloads across the board, plus some that are pretty difficult to figure out how to do well, and add them only as we see need.
So what I'm hearing is V2 is a Tanner style API with like 400 overloads. Is that what's happening?
No, if there was if we got up to 400 new, I would hope that would be V10, and V2 included another 5, and then we added the next 5 as there was a need.
Thankfully, this is recorded, so I can play it back to you next year.
I don't think I'm going to change my tune on that particular one, though. I'm doubling down on it now, so you can really rub it in if I do change my mind.
Oh, that's totally fine. Like, no, I think it makes sense. I think it's a platform abstraction that should live in the platform, so we can plumb it into the places we want, right? So I think it all makes sense to me.
To be clear, like I was pretty staunchly in the camp of this should live above the core and should just be part of some Microsoft extensions library. But a variety of reasons convinced me that we should put it at the bottom.
So speaking of that, so can we talk a little bit about the iTimer thing? So is the expectation that the timer that we ship in threading implements iTimer?
Yes. So Tarek had asked me if I thought there might be any problems or complications with putting this kind of where we wanted to put it in the core library. So I prototyped it out. And in my prototype, I have iTimer implemented both on system threading timer, as well as on some internal types. But yeah, on the public thing as well.
So what I don't understand is, so let's say you call create timer, now you get an iTimer. What the heck are you going to do with the iTimer? Because you can't pass it to anything, right? You can't subscribe to anything. So how is that usable?
You hold on to it, and the primary thing you do with it is you change it. You change when it will fire next.
Oh, because the idea is that the create timer is the thing that passes all this data in already. I see.
Right.
Yes.
Gotcha. And do we expect any other implementations of iTimer besides the fake one?
I think it'd be pretty rare. I mean, we could consider implementing it on, we've got like 4 other timers throughout our core library. We've got system timers, timer, system Windows Forms timer, system Windows dispatcher timer. I mean, you could imagine implementing this on all those, but I don't think those are actually necessary. I think it'd be relatively strange for someone to both implement a time provider, a custom one, like we don't expect that to happen very often, and then for the thing they return from create timer to be like a Windows Forms specific timer. So I would expect that beyond our own implementations and implementations for mocking, we're not going to see, pretty much anything else.
Yeah, I think I'm going to cry if I see a WinForms time provider. That would be sad. So I guess then my question is kind of related to the earlier one. Like, is this an example where we actually make our lives more miserable by not including the fake implementations in the platform as well?
I don't think so.
Because if we were to do that, right, and if we generally think there's only going to be, the system one and then the fake one, right, then we don't have to make it extensible at all, right? Then we can just say, well, there's two API surfaces. Yeah, they're abstract, but the constructors are all private. And so we can completely change the way these talk to each other. Because the expectations, you just use the fake one.
There is many scenarios about I don't think we can make the fake one that can satisfy all different scenarios that people testing with. Like, for example, about there's people need to have UTC now to return February 29 in specific year. Right. I mean, if you make the fake one, you have to provide something callbacks to initialize this, or which is if you re-implement the time provider yourself, it will be easier than just using the fake one.
Or the fake one that I believe we intend to provide is one where you can basically set the current time and manually advance time. But there are other things that you'd care about, like I want to keep a log of all the times that it fired and then revisit that log as part of my testing. If we're not planning on building in that support, I can totally imagine someone wanting to build their own that did that.
There's edge cases like I would like the third call that reads the time to advance the clock, and to test all the edge cases in your code. And so I think it's worthwhile to make this general purpose.
Fair enough.
Yeah, and that, by the way, is well within the purview of what people use existing mocking frameworks for.
Yeah,
they'll say things like, "I want you to keep a log," which we do in some of our unit tests, or "We want every other call to do this other thing," which we do in some of our unit tests, and so on.
Now, the key about providing the fake implementation in the runtime is that it might allow the runtime to be tested in more deterministic fashion.
Did you just call our tests indeterministic? No, I think that makes sense. The only concern that I have is are we really sure we never want to add a member to iTimer? That's kind of what we're saying here, and I'm the argument that convinces me somewhat is that we haven't done it in the 20 years that it exists, but the timer doesn't strike me as this, immutable thing with one member as a logical component, but I guess that's where we are.
I mean, it's a fair concern. Certainly there are trivialities you can imagine wanting to add, like getters for the current period. But I mean, our current timer doesn't support changing anything else. So it's not like we don't support the ability of saying take the current timer instance and replace its callback with some other callback.
Right.
And we haven't seen or wanted that.
Yeah.
But discussion... you could make this an abstract class, though, right?
We could. It would be a breaking change. Either this abstract class would need to derive from Marshall by ref object, because timer derives from Marshall by ref object, or we need to take a breaking change to timer to not derive from Marshall by ref object.
Yeah.
Or we just accept the fact that you have to allocate a different object if you want to use it with a timer, but I guess we don't want to pay the price.
I mean, that is traditionally how a tacked-on mock would work, or a tacked-on interface. You have a wrapper which then delegates. But speaking of delegating, this discussion about fakes earlier is not a delegating implementation, correct?
Correct. So The one we've built for the previous version of this abstraction is completely standalone, just for testing.
Okay. Because I could imagine if we're talking about people subclassing this and then providing their own implementations, I could imagine people not wanting to implement create timer because maybe they only care about giving you the current time, but like creating a timer is just completely outside of the realm of what they want to handle.
I mean, the nice thing
so
for
they want to
tests
forward it
is,
somewhere else.
I mean, the nice thing for tests is you just throw from everything you don't care until proven that you care, and then you implement it, right? So it's very
Oh, I'm not
play
talking about
friendly.
testing. I'm talking about production, right? Because we've said we have production scenarios where people want to do things like replace a time zone, stuff like that, right? Is there a scenario where you might want to replace the stopwatch but still delegate everything else?
So my understanding was that there are no production scenarios of you subclassing this. You either pass in the system one or you call the from local time zone one, and that's all you care about.
Okay, so that means we don't need a delegating one then, because we've identified what we think to be the only places that you ever care to change.
Yeah.
I mean, I certainly wouldn't ship one out of the box right now if it really changed, because you can always implement your own delegating one just by having a fields or just delegating to time provider.system. whatever from your overrides.
Mm-hmm.
If that really became a common thing, we could simplify it. You no longer have to write that one field and all your virtuals by default delegate.
Yeah.
But we're saving you one field and 4 overrides. So unless there was a strong demand for that, I don't think I would push it.
Okay.
The other option would be, someone brought up earlier, rather than having the abstracts be abstract, you make them all virtual and have the base implementation be the system one. And then if you want to just change something, you just derive from it and override the one thing you want, whatever subset you care about changing.
So what's the downside in that approach?
I think the only downside, which I'm not sure how big it is if they're abstract, you're kind of guided to basically say, these are the 4 things you need to provide. You need to provide, the notion of current time, high performance time, callback, and time zone. And if they're virtual, it's harder to figure out the 4 things you need to do. But beyond that, I'm not aware of downsides.
Yeah, and Steve has a lot of experience with this too, with the work that you've done with Stream, because it's not always intuitive as to what you have to override in terms of pairs, right?
Yeah, well, that one's gotten unwieldy with 20 things to override.
Yeah, but so there's the middle ground where none of the methods that applications call are virtual, and then there's a bunch of abstracts that you still doesn't work.
I honestly don't have a strong. I would be fine going either way, either abstracts or virtuals. I don't. It seems like 6 of one, half dozen of another.
Yeah.
It's just not a big interface. So if you need to make it a delegating one, it'll take you 5 minutes.
And honestly, we can do that if the time comes for it. And we can use like HTTP delegating handler or whatever is, an example.
So one question that in chat comes up is like, why did we add the timer one? I suppose it's because it's related to measure how you measure time, and so it made sense to have it as an abstraction here.
That's right.
Yeah. So ideally, when you're running your test, time is frozen until you advance the clock.
Right.
And then, so all the timers, all that stuff needs to be running together.
Yeah, and the design alternative would be that we have a timer factory somewhere that you can derive, right? But then all we have a time provider and a timer provider, and like that seems at some point you just want these other thing that ties them all together again. So
well, yeah, and you want them to be a unit. You want them to be cohesive, so that
right.
when you have your polling loop where every 1 second it does something, when it accesses the current time, it's also a second has advanced. And if those things, if you start needing a different object for each of those, and they can be plugged in, the chances of them getting out of sync,
right,
grow.
Yeah, I buy that.
Yeah. So the effect of when you start using this for real is that at some point you do find discrepancies where, oops, this thing was using the system clock and just moved ahead. And you need to compensate for that. File a feature request, say, hey, they should use a time provider. And that's the virtuous cycle for the next several releases, I think.
You mean 20 years?
You say
No,
potato.
No, actually, I'm seeing like when we exposed like time only and date only, I was not expecting much usage. I mean, like, but I found like a lot of demand on that and many people using it. And so maybe time provider will be the same. I mean, like many people will start using it and just be very popular.
So if you look at Microsoft's own services, nearly every service has an iClock or iClock equivalent. So there's hundreds floating within the company.
Yep.
Right.
So yes, it will be popular.
Yeah. And iTimer also. There is some places they are using iTimer. Okay. Should we continue? Just we have an hour.
Yeah, that makes sense to me. I mean, I think is there anything else you want to oh yeah, there's a lot of APIs you want to never mind.
Yeah, this is how we are going to use the time provider inside our own types. I mean, so first about like, our timer class is going to, to implement the iTimer interface that we are exposing. This is naturally. And we have the cancellation token source. We are going to expose a new constructor that it takes time provider, which is you can now control the cancellation token with the time provider, like cancel after some period or something like this. It will be using time provider at that time. The next one, of course, periodic timer. Also, we are going to have a new constructor taking the time provider, which is you can control the periodic timer through the time provider itself. Last two is on the task. Wait async, which is like it takes time provider also, so you can perform the wait async using the time provider behavior. This is basically the APIs that we need to change for inside the .NET 8 core. Yeah. And we are going to provide some extension methods similar to those when we are running on the down levels, just to support the down levels, same functionality.
Could you, whoever, I think it was email screen, email, could you scroll down a little bit?
Yep. Oh, you mean the down level stuff, yeah.
Actually, one thing, go back. Tarek, this doesn't have delay, but that was one of them too, right?
Delay? No, I don't think we proposed delay. I don't remember. I think we said that wait async only is one within what we need. Okay, maybe I missed it from your prototype or something, but
I'm 99% sure I prototyped delay as well. But
okay.
But I would expect that delay would be a very common desire.
Definitely, it's part of the gang.
And that's a static method, right? And it would just take time span and time provider then?
Correct. There's two overloads that I prototyped: time span and time provider, and time span, time provider, and cancellation token.
Gotcha. So we wouldn't do the int-based one.
Right. In general, I think the proposal for these, we've been slowly but surely places where we only took an int for milliseconds. We've been adding time span overloads there, and I think in many places where we've proposed brand new APIs, we've only done time span. So I think the ideal here would be, if we need to add a time provider based thing, we're only doing it for time span.
Yep.
Yeah, I pasted in the chat the delay ones. Sorry, I missed those, Steve. I did not see. Sorry.
No problem. I mean, I think I'd only prototyped them because you had them in your previous proposal. So, yeah.
Are the cancellation tokens optional?
We have a choice. Like there's two methods currently on the stream: wait async that doesn't take one and wait async that does take one. Either we provide both of those, or we provide just one where the cancellation token is defaulted.
Didn't we?
I don't have a strong opinion.
Didn't we have the guidance that says do that? Jeremy?
Right, possibly.
I think most APIs today have just make the cancellation token optional.
Yeah, I mean the guidelines we wrote for methods using the task-based async pattern is you should take a cancellation token named cancellation token and it should be defaulted.
Yeah, so then we add default to the second in the pair and we remove the first.
Yep.
Right. Now, if task is special and there's a reason that wait async with no cancellation provided is perf critical and fundamental and Steve says he needs it, then I would not object.
No, I'm fairly certain the implementation would just delegate from the former to the latter anyway.
Okay.
Sounds good. Should we look at the low-level stuff then, or anything else?
Yeah, the down level stuff is exactly like matching the same functionality we added to the core, which is wait sync. We need to add the delay one, which is we missed in the core. I mean, so we need to add also the extension methods for the delay.
Right. Yeah, we just make
But
the
exactly.
extension methods on a new type, basically.
Right.
Yes, I
And-
think the wait async ones are sort of no-brainers. We figure out what type that we put them on, but they will look, from consuming code, they'll look exactly like the instance methods because they'll just be extensions that have the exact same shape from a caller's perspective. The other ones are trickier. Delay, we can't currently, maybe this would change for C# 12, but we can't currently have static extensions or extension statics. Nor can we have extension constructors. So both delay and cancellation token source constructor would have to be exposed in a different fashion.
Yeah. So, I mean, my other question is, would we ever put the type in box? Probably not, right? We would just say they're purely in the out-of-band library and like it's fine, right?
There's no reason to, I mean, I don't know of a reason to put them in box.
Right.
The functionality is all there in a better place. You'd want them implemented to work on, the OOP component would implement them on .NET 8 to call the relevant method, but
Yeah.
So if I'm using those, I'm building with .NET 7, I'm using those extensions, and then I upgrade to .NET 8.
Yeah.
Do I get compilation errors at that point?
No, we
Or-
prefer the
no, it'll
instance
just prefer
methods.
the instance methods.
Yeah, it just magically binds to
So I'll
them.
just silently use the other one. Okay,
Yeah.
that's
Yeah.
cool.
Yeah, there really
Or the
is
wait
no-
async ones, not for create cancellation token source, obviously.
Yeah.
So we need to figure out, where these things should live, if we want them where they should live, and what we want the consumption model to look like. Like,
Yeah.
do we want? In general, we haven't asked people to call static methods on extensions types, but that's what create cancellation token source as it currently looks like would be.
Do we already have a type called task or time? I guess no, because we don't have time provider. The guideline that we wrote is don't create types named extensions.
Yeah, I mean, so what we have done in the past, which I think was not insane, was we shipped a type called task ex, where all the extension methods went and also the static methods like delay went. And
So
then-
we did back in the .NET Framework 3.5 CTP for async await.
Yep,
or whatever it
that's when we did
was.
that. And I mean,
Back
honestly,
in the day.
usability was reasonable, right? Like I don't want to call a type called, task oop extension stuff dot delay, right? That would be pretty awkward. And quite frankly, for those helper methods, I don't know what else to call it. it is basically just a grab bag of stuff we couldn't put on the actual type, right?
Yeah, I mean, I just noticed that Tarek actually defined the create cancellation token source one as an extension method as well on time provider. I would rather do that than have static methods on some public task X.
Sure, but what do you do with delay? Do you really want to have this an instance method on time provider now?
Yes.
Yuck.
I think it's less yucky than taskx.delay.
Or just saying maybe we get extension statics.
Yeah, extension statics would be perfect for delay. You still have, unless you have extension constructors, you still have cancellation token source.
Didn't you say we get extension everything if we ask hard enough?
Did I say that? I was probably expressing a wish.
Yeah, I mean, like, it's an interesting example where this would work. I mean, we could do that. I mean, I would just say then, we should do the inbox, like the inbox version should have an extension method. Like, it wouldn't be an extension method, then it would just be a static. So it would just be an instance method on time provider then, right?
Yeah. There would be no need to make it a static method or an extension method.
Yeah, you basically make wait async extensions on task and delay and create cancellation token source extensions on time provider. And then you put them on some hidden extensions class, whatever you want to call it, that no one ever uses directly.
But why would you make them extensions on time provider? Why wouldn't you just make them instance methods on time provider at that point? Because you can touch them both at the same time, right?
Because we don't want to provide these as instant methods on time provider. I don't want these in box.
Oh, so you don't want them in box, not even on .NET 8?
Right.
Oh,
No.
okay.
These are polyfills. The functionality exists already in .NET 8. There's no reason to duplicate that functionality. We're just trying to make it available down level.
Right.
Yeah, at that point, then having an extensions class available only in the OOB seems appropriate.
Right. I'm not saying it's really bad just to have an extension method for time provider.
Honestly, like, I mean, we should think about this, but I wouldn't mind the EX suffix for these kind of things because it's an ugly name we would never put in box. And if we say these polyfill types we never want to put in box, I think it's nice to say there is a natural place where you would look, right?
Yeah.
I think if we're going with the EX name meaning extensions, then we're just back to the...
Well, it wouldn't mean that. It would more like the thing that is not in box, right? It's where we can actually touch. That's where we can put stuff that we can't add to existing types.
Well, I would also want us never to ever move that X type in box because that way we could keep versioning it out of band.
Exactly, right? So that you want this place so you can always add new stuff to it so you don't end up with EX2, EX3.
But
Yeah,
that still
'cause I-
doesn't solve all the problems. Like you wouldn't have cancellation token source X because you'd need to, if you were trying to actually achieve the same sort of use as what you have in box, it would be new cancellation token source X. And I don't think we're going to do that.
No, yeah, it wouldn't be for static methods. It would only be for statics, right? It would not be for instance. Yeah.
I mean, this is all, a good argument to really push on static everything, right? To say like we're contorting our stuff as a result of not having this feature.
I mean, static everything is in the works. It's all the roles stuff. I just don't know how much of it is going to land for .NET 8, nor do I know how much of it will work down level.
And also, it's not clear to me that the syntax is always a drop in, right? You might still have some syntax differences, right?
I mean, if I had my druthers, it would basically be we make the .NET 8 experience great, which I think it'll be. We have all the relevant things in the right places, and then we make the down level possible. And we make the down level possible by putting extensions on time provider. And if you're using the extensions, you do time provider.wait, time provider.delay, time provider.create, and it just kind of works.
Yep. The only problem is like the name is not as unimportant as you might think because it will show up in the documentation of everything, right? So if you ship it out of band, it's still in the TOC for everybody. So I still think we should put a name that, you know, is not like polluting the namespace, or if it does, it's clear that it is what it is, right? So I want to say time
so
provider.
this would be under system threading tasks, even though time provider is under system. So is the name that important?
I'm not sure that's the right namespace for it, actually. Presumably, I mean, don't we usually put extensions types, whatever they're called, in the same namespace as the thing they're extending?
Normally, yeah.
Depends.
Well,
we don't
normally
do it
no.
for link,
I
right?
mean,
So-
link is weird, but
well, I mean, the reason why you want to put it in a different namespace is so you can selectively opt into these things, right? So, like, if you put them in the same namespace, then that only makes sense for cases like here where we just fundamentally can't put it in the right place for layering reasons, right?
Yeah.
Versus with link, it's an example of like usage, right? Just because you use any rule doesn't mean you want to use all the 400 extension methods over it, right?
Yeah,
well, I mean,
it's
we
a
added that
question of
and
why
task
you're
to the
making the
default
extension
namespace.
method.
Yeah.
Well, there is that, but that is every time we ever invoked IntelliSense on string knows that this is a double-sided sword.
I mean, maybe it doesn't matter in the end because this is a default imported namespace now.
Yeah, that's
So,
true. Both threading
whatever.
tasks and system is important, right? So that,
Yeah, as is link. So put it in system link.
oh, Levi,
Yeah.
that gets you on my naughty list for today. So yeah, I mean, honestly, like, we should put it in where it belongs, right? Given that they all, I mean, not all, right? Some will extend tasks, some will extend time provider. So either pick is quote unquote wrong.
Yeah, but the ones that are an extension method on time provider, if the idea is that the real, if you're using .NET 8, it's no longer an instance method. It feels weird that we'd call it an extension method in the polyfill, because you're not polyfilling at that point. You're being a completely different thing.
Well, I
Well,
mean,
it's
like,
an extension because it's provider.create cancellation token source. I mean, it's an extension on time provider, and it's polyfill just in that it's creating the same capability down level, even if it's not a constructor on the other thing.
Right, but you don't have the in net 8 you can just remove the package reference and everything works. It's in net 8 you remove the package reference and then rewrite your code.
Sure.
Yeah, but
You don't have to, but you can.
So what's the motivation for having two different models? If the functionality can be achieved through extension methods on the down level platforms, then why not deliver the feature the same way in .NET 8 as well?
Well, it can't actually be like, so this create cancellation token source thing can't do it as well without support in cancellation token source. So this is a best effort, but it's not. For example, cancellation token source has a try reset method. That try reset method needs to know about the timer, and it won't. It'll produce the wrong answer in some circumstances if you're using this extension pre.NET 8.
Yeah.
I think fundamentally, like, yeah, the reality is you can't provide the things in the places where you want. So the down level stuff will always look somewhat bolted on. The decision you can now make is whether you want to put the bolted on stuff also in box so people can just drop the package reference, but then you make it, slightly less pretty for everybody else, even for people that don't care about down level stuff. So it seems more desirable to say, hey, let's make the inbox one pretty. And then we say, like, for the down level stuff, we have some helper methods that, are living in the package only.
Makes sense.
But when users migrate their code from using, like, from .NET 7 to .NET 8, they need to change their code at that time, right?
They won't have to, but they can.
Yeah. You can ship the package forever, right? Like,
the package will include a .NET 8 asset, and the .NET 8 implementation of create cancellation token source will be new cancellation token source time provider.
Okay. Yeah.
So then we say the extension methods here for delay would be time provider as the first argument, time span delay, and then the defaulted cancellation token.
That's right.
That works for me. And then we're still happy with the name time provider task extensions because, well, why not?
I mean, the guideline we wrote is you should try really hard to name it in a way that would be reasonable to call it in a static approach, and then just let the extension methods fall out. We said naming things extensions is an anti-pattern, but if it's a complicated polyfill thing that we don't really have a thing that we can base it on, then that means we're out of the guidelines.
I mean,
What would the guidelines say we do name it? We can't name it time provider because that already exists, and we want to create extension methods for time providers. So what would the guidelines say we do?
I mean, the guidelines say name it for its functionality, and if really this is just that it's extending the type in a different assembly, then I guess that's the best we're going to get. But the idea is pretend extension methods don't exist. Design the type. Now put the this is on, is the approach that it suggests.
All right, time provider task helpers.
Right. I mean, yeah. But, as for the EX suffix, from the Christoph era, like, there's specifically a guideline, do not name public types with the EX suffix.
Yeah, but that's different, right? That's kind of the, if you need a new type, do a new type. This is really for, we ship a polyfill out of band and we never put in box, right? So you get away with a single version of that. Otherwise, you make your life miserable. But that was just a suggestion. We don't have to do it. I'm happy with time provider task extensions as it is here. Because given that everything is extension methods on it, nobody will ever refer to that type. So the only question really is now what does it look like in the docs? And I guess that's the most, I guess, established pattern that we have, for better or worse.
Yeah. And it's honestly not the worst sin to put a non-extension method on there as long as we're judicious about it.
Yeah, I mean, the reason, that's why we have the guidelines, right? Because if you call this method statically now, it's just super weird.
Yeah.
So is there a filter in the docs where I could say, show me the .NET 8 stuff, and these methods would not show up?
Sort of. So there is a picker that you have. The problem is the experience is weird. I don't think it actually removes them. I think it's just when you click on them, it tells you that they don't exist in your target, I think.
Well, I mean, there's a question of if the filter would drop the things that are listed in because there's like .NET 8 and then there's .NET 8 with platform extensions, and so it's if you get rid of the with platform extensions, will it get rid of the members that are from DLLs that are later? And I don't know the answer to that.
Yeah,
probably does,
because they exist in .NET 8, just not in box, because they're consumable from .NET 8.
Yeah, well, we just don't want people to use them.
But they wouldn't be part of if they're only in a OOB package, then that would mean that they would show up in docs only under platform extensions. But I don't know how platform extensions providing extension methods on types that are in the core. I don't know if the docs system ends up unifying them.
I think the whole setup in the docs page is kind of ad hoc. So it's kind of we configure that we control what's in there. Like we would just say that this OOP package, you would just not put into the normal .NET moniker. You would only put it in the .NET platform extensions thing, which is why normally it wouldn't exist. It would be filtered out. So it's probably not a concern, actually.
We can control that ourselves anyway, I think. Like we control the docs stuff.
Ish.
I mean, you can decide not to document it at all. That's an option you can take. But I think like if you have a documentation, I think there's limited options of like how the filtering works. That's just how the tool works.
Yeah. Yes, this is one of those things where the tool defines the process, not the process define the tool.
Yeah, there's certainly an element of the tail wagging the dog, unfortunately.
We have really knowledgeable people on the docs team though. Like I bet they could guide us here.
They can guide you. It's just whether you like the direction they're guiding you into. But yeah.
But at least they could help give us some kind of consistency.
I mean, it'd be like the compiler team. They tell you, yeah, this is a feature we could write, but it'll take 20 years. If you want to make it work tomorrow, here's what you should do instead of the thing you want us to do.
So question, since we're about to hit the big green button on this, we decided that task extensions should go on in system threading task, not system, even though they're extension methods on time provider.
Well, I mean, they're both, right? They're both on task and time provider. So take your pick,
Oh, they're
right?
on both. Okay. Yeah, never mind. The other question I had was the static factory that we had, time provider dot from local time zone. Should we drop the infix local there? Because local implies your local machine. Because we have things like time zone info dot local, and this is not local. This is like I'm explicitly telling you what to do, which may or may not be related to my machine's local time zone.
But it would also apply to the property, right? Would it not? I mean, there's a property called local time zone, and there is a from local time zone.
Right.
So would you drop the local from both then?
Yeah.
Probably.
Why not?
I mean, that's a fair question. I mean, like, I think it's just, you know, I think because you have UTC now and you have local now, right? You want at least local there, right? Because you want to differentiate between the UTC one, the non-UTC one, and then from there it just propagates, I guess.
So maybe with local time zone instead of from, but now like with is its own thing.
Well, with would make sense as an
really,
instance, right? But given that it's
yeah,
aesthetic,
it's really just a nit. Yeah, it's a nit more than anything else. It's just it just strikes me as strange because local time zone actually does have an honest to God meaning within .NET, and this is the inverse of that meaning.
interesting.
They're just talking about the difference between like from local time zone and from time zone to use as local, basically.
Something like that, yeah. It's really not the worst thing in the world.
That .NET has a real deep core intrinsic understanding of what a local time zone is that is distinct from what this is saying. This is just saying that instead of it being the thread or process affinitized thing, that it's the instancy thing. So it's still the same. How do you want to translate to and from UTC? Like, we're not changing the meaning of that.
Okay.
We didn't resolve some of the other conversations that we had earlier. I realize we're at time, but we had discussed the notion of having everything be virtual, and just having the base implementation be system, or having a timestamp frequency being non-virtual and delegating to some sort of virtual or abstract core.
That is true. Like what I heard from you though is that there is a proposal that you want to think about, and so I think if you want to do that, then you would come back and say this is what we want to do now. But I feel like we can also go ahead with the proposal as it is right now. So to me, that would be a DCR kind of thing if you want to.
I think the one of timestamp frequency being non-virtual and calling a core to just really cement.
Yeah, that's what I said here.
You cannot change this. Okay.
I basically called it out, but I didn't design it here. I just said like that's something you want to do. But for the other one, like I don't feel as strongly, I think, whether we make them abstract. I mean, I think Jeremy is onto something when he says you can only do it once anyway. So maybe just design the whole thing for virtual already so that it's always consistent with whatever we add later. But I don't.
Yeah, I mean, so there is a thing we've talked about in the past, which I'll bring up just so we think about it in terms of this, which is we talked about early in core that we could take things that are virtual throw, you absolutely must override this or things just aren't going to work. And in the ref assembly, call them abstract in later versions, so that if you had the minimum target, it would tell you, no, really, you have to override this. So we have talked about not breaking the runtime with the runtime saying abstract, but doing something with our ref assemblies to make to give the signal this is something you really, 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 really need to override. AKA,
you mean to be able to add new abstract methods in the future,
right? So that we would the implementation would be virtual throw, but that the ref would say abstract. So if you see the new TFM, it says override this, or we're not letting you compile. That's a thing we started talking about early in the process. I think the tooling was going to make it hard for us, and we didn't stop and think it through. But it is a thing we've thought of in the past. Or, Emo may just say that the answer would be we put an attribute on it of like, override this if you want things to work. And then we catch it with an analyzer. But
Sorry, what's the benefit of making it virtual but saying it's abstract in the public?
well, if you
API?
say it's abstract in the implementation, then if somebody upgrades to the next version, the runtime will say it can't fill this slot, and the runtime will shut down.
Yeah, this is not
if
about
you-
V1, it's about V2, right? In V2, you don't get to
I
add
see.
new abstract members, so you have to make it virtual. So you basically have the soft virtual where it's virtual, but then we or soft abstract, right, where we throw in the implementation because it's the only thing we can do.
Yeah. So, but making it say virtual in the ref, or sorry, abstract in the ref where it said virtual in the implementation solves the runtime problem and the compiler hint problem. But
Yeah,
That
it's
was-
just really messy in the long run, right?
that was a
Because
thought pattern that we didn't finish. So
I think we just don't like this, permanent difference between ref and dev because then you just every time you sync it, you have to undo the change basically.
Indeed, I mean, like I think it's we would put an attribute of some sort on the things we wanted to do that to and have the tooling do the right thing.
Sure, that's probably doable. Yeah, that's fair. Sounds good.
So
Then-
it's not that abstract absolutely can't be added later. It's just we've not come up with the process yet.
So I just want to make sure I know what I heard. I think what you're basically saying, Emo, is we're agreeing to the API as is, or if Tarek decides he wants to change the abstract timestamp frequency to just be timestamp frequency delegating to a timestamp frequency core, that's fine. And then any other changes we want to make, such as making everything virtual, whatever, we'd come back with a separate proposal.
I mean, I'd go further. I object to timestamp frequency being abstract.
So you want
Yeah,
to change
if
it
we
right
didn't
now?
want it,
That's
if we
fine.
didn't want it to be abstract, why wouldn't it just be something you pass it in the constructor? Like that forces you to specify it.
That sounds smart.
I mean, that's also an answer.
I mean, it's
Would-
required to create one of these things, so
That's reasonable.
and we just say like, sorry, DI, or there's some intermediate that someone creates somewhere which says screw it, stopwatch.frequency is the default.
Yeah, I mean the difference between it being the constructor thing versus the abstract core member is if you, I don't know, wanted some complicated pulling it from config that you're going to end up with a creation cycle order, but
Well,
I'm
the-
fine saying it's a constructor parameter.
It being a constructor parameter also guarantees it's immutable, which it removes an entire class of problems of people who try to mutate frequency, even though that's basically ill-defined.
No, but the non-virtual property calling a core protected abstract get timestamp frequency core would be that you could still lazily produce your one value. I don't think it's important. I'm just pointing out it as the difference between the two proposals.
Well, I don't think this is the. So with most timers, you don't want your timestamp frequency to be lazy because it's a core part of everything else, and it's a cheap one-time lookup.
Mhm.
But yeah, that constructor parameter until somebody says why that doesn't work seems good to me.
It's good.
Yeah,
And-
I mean it does make mocking more difficult, but maybe we just say that's not a problem we're worried about here.
Yeah, what I heard is that you basically don't want to mock it in the trivial sense anyway. You want some more convenience around that with advancing and freezing time and whatnot. In which case, it would be more involved anyway.
I think the overwhelming majority of people, 99.9% who mock this are interested only in overriding UTC now and absolutely nothing else.
Yeah, I think the one thing I would agree with is that regardless of what this type looks like, I think we should probably look at the fake one and decide whether we want to ship it or not.
I mean, you could add a default, an empty constructor that just used the system frequency.
Well, that's
Yeah, but
inconvenient
that's
for the
easy enough
writing.
for somebody to pass.
Yeah.
Yeah.
Like,
I mean, if you really want to do it, it would be a factory method, I think. But yeah, we could do that. All right, I really need to see the restroom now, so I'm gonna call it a day. And then we can take the other discussion later. Does that make sense?
Yeah.
Happy. All right, then I see you, I guess, Thursday, right? Bye-bye.